Hi everyone. In this video, I plan on describing how we actually generate arrival files from our noisy bathymetry data and how the general pipeline works. So again, if you go to the GitHub, you go to bathymetry, go to AGC26, and then go to the folder AT, which again stands for Acoustic Toolbox, you can find this file generate_noisy_data.m, and it is right here. This is the pipeline to generate noisy bathymetry files, generate corresponding environmental files, generate arrival files, and then finally how to generate the WAV files, which I'll talk about WAV files or .wav files specifically later. So these are the inputs for the training data for the neural network. So to just go through this code, function product equals generate noisy data. The two inputs are bathyfile, which is the pure, unaltered, unnoisy, ideally, bathymetry file that either you get from simulated data or that you get from somewhere on the interwebs, NOAA, from whatever agency has generated some coarse bathymetry file map. So this can either be precise, perfect simulated data, or it can be very coarse if we wanted to generate noisy data from that, which in certain situations we do. The second input is J. Now J is how many noisy files do we want. And if we're training the neural network, we want this number to be in the thousands. 1,000, maybe even up to 10,000, which is very doable. We want as much noisy data as possible for our training validation and for the hidden, for the shallow neural network, for the hidden layer, for everything that goes involved with that. So I equals 1, k equals 1. We enter this while loop, which just goes from I to j being the number of files we want. Open up this bathymetry file, the pure one. We go through and create a new name for the copy. We find the matrix size in the bathymetry file, which if we pull up an example is, in this situation, 38 by 96. We then generate a new environmental file that will be associated with this bathymetry file. You have to have at least some environmental file to actually start this process. In this current iteration, we use the same environmental file per new noisy bathymetry file. We just need like a specific one to base our bathymetry file off of. They need to share the same name, and if we rename the bathymetry file because it's noisy, we need to rename the environmental file as well. This function right here calls the Perlin 2D function, which is talked about later, which is talked about in an earlier video. And this line right here generates the noisy bathymetry files. Again, talked about in an earlier video. Finally, we use the extension bellhop 3D to actually simulate an arrival file from this bathymetry file and from this environmental file. So an arrival file is bellhop 3D's way of calculating the amplitude and the travel time of every echo, or rather the amplitude and travel time of every ping as is the sonar data. So this is invaluable as this is the basis for how we create our waveform files. So bellhop 3D is one of the main limitations to the neural network software and to how we generate this training data, how we generate the neural network. It's located in AT. It's located in the folder bin, finally bellhop 3d.exe. So it calls this function. One very, very important thing to note, if you want to run any of this data, you have to be in the bellhop folder in the Acoustic Toolbox. This bellhop folder contains all of the Fortran code, the .f90s. Here we go, bellhop 3d.f90. You have to be in that current folder in order for bellhop 3D to actually work. So the way to get around that is if you go to AGC26, go to Acoustic Toolbox, right-click that, hit Add to Path, select the folders and subfolders, then go into AT, go into bin. Now you have access to all of this code, all these functions, while remaining in the bin folder. Oh, sorry, not the bin. You have to go into the bellhop folder, while remaining in the bellhop folder. And that's very important when you try to generate any sort of data. You have to be in this bellhop folder as your current folder. So this is how you generate arrival files, which again, arrival files are just the amplitude and travel time of the echoes from the sonar data. I hope you like and subscribe this video. Again, I want it, please. I need that kind of validation. And I hope you watch the future videos. Thank you.